Good morning, Soad, and good morning, Jayla, for sure. Okay. Good morning, Daniela. Good morning, Alyssa. Good morning, Noel. Good morning, Charlie. Good morning, Jayla, for sure. Good morning, Vivian. Good morning, Charlie, for sure. I'm saying for sure because I can see them. And because Jayla was here since like 1967 this morning, or so, not quite. I mean, yeah. Okay. And so was Charlie. Okay. Good morning. Right. So good morning, Jayla. Good morning, Vivian. Good morning, Charlie. Good morning, Noel. Good morning, Daniela. Good morning, Alyssa. Good morning, Soad. Did I lose Soad? Oh, yeah. So it's there. Okay. Okay. Oh, Lakshmi. Good morning, Lakshmi. I think. Okay. Okay. We're going to start, I think. Oh, wait, no, we're not. Okay. Okay. Good to see you guys, especially those of you who I can see. Okay. I'm. Oh, thank you. Wait, thank you. Wait, that's weird. Did I tell you guys that? Weird. Yes, right. We can't. Thank you. Right. Yes, thank you. I appreciate it. It was very nice. Right. It was sort of at your expense. That's right. Thank you for reminding me. Okay. I mean, thank you. Yes. Okay, right. So I haven't seen you guys in a while. I knew there was something awkward in my mind. There was some clog in my throat because I haven't seen you. Right. Oh, I did mention it. Oh, okay. 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 All right. But also, I know we didn't have class last Wednesday. That's what I almost forgot. Oh, I mentioned it. Oh, right. Oh, I see. So you really watched that. Good for you. Okay. Thank you. Oh my God, that's right. And I think I said mean things that I totally take back, and I was just kidding about. Right. Okay. Okay. Yes. Thank you for. Okay, I'm going to look at the chat again. Right. Thank you very much for watching that. Yes. That's great that you watch. I mean, I know I asked you to, but that doesn't mean it always happens. Right. We didn't have class last Wednesday. Thank you for watching the other lecture. Sorry if I think I spend each class making fun of the other class sometimes. Right. We're going to get back on track today. I want to do more with equations today and equations as they relate to the homework. One important. I did. Okay. Yes, please do send my. No, it's true. She deserves a prize. I mean, I get a present on our anniversary, but she gets a prize, and it's like a consolation prize, and it's like an endurance prize. You can only imagine. You can't even imagine. Even she can't imagine what's like living with me. And good thing she doesn't spend a lot of time trying to imagine. I mean, literally, I can't even live with me. I don't even know how anybody, but I have no choice, you know. But anyway, but we did have okay, but right. To get us back on track, not that I'm embarrassed, not that I'm getting caught up in the other topic. But here's the most important thing for us physics people. Huh. Wow, that's nice of you to say. Okay, I appreciate that, Jayla. And you know, right back at you. I mean, seeing your bright, shiny mask face twice a week, totally. And I do mean that actually. Okay, I'm going to stop. I'm going to try to get back to physics for a second, but right, you've all put perspective on. Oh, thank God someone has interrupted by actually coming to class. Hold on a second. Sorry. My God, can you really? And you know, if I'm this, I want to say this to you guys and perhaps 10,000 other people. If I am this awkward at teaching physics, can you imagine how awkward I am in real life, because really, like, and I'm going to say this with total humility and arrogance or whatever, like teaching physics is the one thing I kind of do know how to do. Like I've been teaching physics again since 1992, right? It's the one, in fact, other people in my life have said like, it's the only place that I'm sort of comfortable. And if this is my level of comfort, can you imagine? I mean, it's preposterous, but all right. Okay, right. Those who cannot teach, those who cannot teach physics, right? Old saying. Speaking of not teaching physics, I want to address an elephant in the room, or a donkey in the room, which is exam. Here, there's bad news and good news and good news and bad news. Exam, we are going to have one. We had once said, I don't know if those of you who like are tracking this or whatever, I actually had said like 2 weeks ago that we would have an exam this coming Wednesday, like 2 days from now. Now it would be online and posted and all this stuff, but it was going to be 2 days from now. The mixy news is no, we're going to postpone it. I mean, the reason I didn't talk about it at all last week, or the fact that I didn't talk about it at all last week, or that I didn't give you a practice exam yet or review documents, okay, well, is a failure, but it's also, I don't know what you thought of that in your mind, but I had said that when you have an exam, you always get a practice document for that exam, and we talk about it, and we like prepare ourselves for the exam. Now, in theory, we still could have time over the next 2 days to do that, but we're not going. So for good or for bad, let me tell you right now, I had a long conversation with Professor Walters. Actually, I had two, one this weekend and one this morning. You can mark your calendars for good or bad. We are going to have an exam, and I hope this doesn't conflict with other things. Get back to me if it does, if it conflicts with Orgo or something like that. I apologize, but we're not having an exam this week. We're not having an exam next week, but 2 weeks from this coming Wednesday. So that means, let me look at my calendar. I'm sorry. So, but please do mark your calendars with this. And actually, let me say too, because I do kind of want to get back to the topic, and I don't want to create more awkwardness. I will tell you right now, I'm going to give you a little bit of details right now, and I have done this in the past, but we're postponing again. It's because we didn't prepare you. I mean, you would be too out of nowhere to just suddenly get an exam this Wednesday. What I am saying, hold on, I'm opening up my calendar. I am saying, wait, sorry. Yeah, I am saying November 11th, please mark your calendars, that November 11th in the evening, we will post, that's Wednesday, November 11th. We will post in Google Classroom a midterm exam. You will have until the following Monday, like class time, to turn it in. So it's a take home, untimed, open universe, i.e. open notes, open internet, open whatever, exam. It will be on the material that we've covered to that point. I'll be more detailed about that soon. You will, and this is serious, I don't mean to be scary or anything, but just to be as clear as possible or as serious as possible, prior to that time, you will receive a practice exam that you will not be getting a grade on. You will not turn into me for a grade or anything like that. In fact, technically it's not required, but you'd be very, very unwise not to do it. You'll get a practice exam like a week before then that will be identical in format and nearly identical in substance, like 85% or 80% identical, and 100% similar in substance content to what your exam will actually look like. Okay. And again, I hope everybody's like following this. And wait, there's something in the chat. Maybe this is about, oh, it is. Oh, wait, I'm sorry. Thank you. Wait, oh, that's a Thursday. Wait, what am I looking? It is. I'm sorry. Hold on a second. November. What did I just say? I said, oh, I'm sorry. You're quite right. November 10th. I mean, I'm sorry. Thank you. I'm saying, yes, thank you. I think that was Alyssa. I'm sorry. Wednesday, November 10th. Thank you. And so that proves at least one person is super paying attention to what I'm saying. Thank you. And at least one person is certainly looking at a calendar. Thank you. I mean, Wednesday, November 10th. Wednesday, November 10th. Wednesday, November 10th is when the exam will be posted, like in the evening after we've had classes. We will, and I'll try to arrange it to make sure that we actually do meet that day. I know sometimes we don't on Wednesdays, but that evening I'll post the exam. You'll have Thursday, Friday, Saturday, Sunday to do it, to turn it in via Google Classroom by Monday before class period. As we get closer, I will be more detailed. I will talk to you more about the details and the rules and stuff like that, but you will a week in advance, or approximately a week in advance, you'll get a document that really looks a heck of a lot like what the actual document will look like, and you'll be able to practice with that document in advance. You'll even get some solutions to it, maybe not all, but you'll get some solutions to the practice exam. You'll have an opportunity after you try it on your own and with each other, after you like try to work it through this practice exam with each other, you'll have an opportunity on the Monday and the Wednesday of that week to ask questions about that practice document. And we will talk about the practice document, i.e. we'll talk about the exam before it actually happens. That's one of the reasons it's not happening this week, even though for those of you who were tracking this, we did originally say it was going to be this Wednesday, but we just haven't talked about it enough. Okay, to be fair in our minds. Okay, so all that, so you will get a practice document. It will be an opportunity to like really grind in the details and the concerns and the stresses, whatever, which is another reason I'm not going to get like too into that right now, hopefully, or today. Okay, but the basic expectation is you get a practice document, you do the practice document, you don't turn it in, you do it for your own sake, you do it with friends, you do it to see. It is the way of studying. To be really blunt, like it's not about reading a textbook. It's not about like memorizing a bunch of things from your homeworks. Oh, the exam is written from your homeworks. The exam will be like 4 big like homework problems, like fact pattern, then part A, what's the velocity here? Part B, what's the acceleration? Part C, like just like homework problems are increasingly looking, it'll be like that, like 4 big versions of homework problems or so, of which you'll choose 3 or something like that. Like, again, these details you'll see for sure on the practice, but broad stroke expectations. An exam in physics in this course, in this program, looks like 4 or so big homework problems where you show all work and you do everything according to the method that we've been trying to drill in, like the 5-step problem solving procedure. That's anything you've ever done on a homework that you feel like you've done it all right, that has been literally for the purpose of practicing for taking a physics exam in this course. Okay, it's all like the same type of approach. So you'll get the practice document will have a sheet of equations at the front. It will have the equations at the front. You'll be able to ask questions about the practice document before you take the actual thing. The actual thing will be posted on Google Classroom, and then you'll submit through Google Classroom as though it were just one big homework assignment, only it counts as an exam, but it's like one big homework assignment and sort of graded that way too, but it's worth 100 points. It'll have like 4 or so problems on it. You're going to choose like 3 or so out of those problems. That's pretty much a promise, and that's partly because different sections sort of emphasize different things. So you'll be able to choose the problem that you feel that you've really emphasized in your particular class section or in your particular studying or whatever. Okay, like you'll have some degree of freedom on the exam. When you do it, you're not going to do it under test conditions. You're going to do it at home, at your leisure, in spurts and spots, if you like, as though it were a research paper. Like in many ways, it really is sort of more the approach of a paper or a research paper than like a sit-down exam, okay? Just to make that clear to everybody. We will not stop you from going on the internet when you take this exam. We will not even attempt to stop you. We will not stop you from talking to other people when you take this exam, including or especially your friends in the class. Secretly, we hope you do. Well, it's not much of a secret because I just said it, but we will talk about that more as we get closer to. In many ways, you will possibly think that I'm joking or think that this is like a gift or something, because in many ways, our approach to giving you an exam is in many ways far looser than maybe you're expecting or than you're used to in other classes. Like many of the things that you would normally consider cheating, we're saying go ahead and do, and we're saying they're not cheating in this context. And if you're hearing me at all, then hear me loud and clear. Like, a lot of the things that you might think of normally as cheating, we're saying is not cheating on this exam. And I want to, and as we get closer to, I would, and this is one of the reasons that we're not doing it this week. I want you to be prepared for it. Let me say again also, if we've now picked a date that really messes you up, or the fact that you were thinking it was this week, that the fact that we've now postponed it or pushed it into semester really messes you personally up, send me an email or send me something personal about that. And if you have a real personal issue, like a specific issue to you, I might even try to accommodate it depending on what it is. Or if you think you're speaking for the group, if you're like, we all have an orgo test that day, like you're not being sensitive to that, Yaverbaum, like just let me know that, and I will take it into account. Again, I'm trying to, as usual, do two things at once. I'm sort of trying to make this all clear to you without like spending the whole class period discussing it right now. I'm partly postponing it so we can get back to material for a couple of weeks. But if you have any concerns or issues, please send them to me personally, and I will address them. If you have specific, like, if you're like, no, the date is fine, but I'm like freaked out how this is going to work. As we get closer, I'm going to tell you more how it's going to work. But the overall big message I'm going to send all of you, and I've done this and I am serious, it's going to sound like a gift or a joke to some of you. And maybe it is a gift, but it's not a joke. One of the basic reasons that a lot of the things that you would normally consider cheating, we say are not cheating, is precisely so that they won't be cheating. Meaning this, in my heart, and we've tested this in many ways in physics, in many ways in the past, and in both pre-COVID and during COVID. My feeling is what's really cheating, and I don't believe in cheating. I don't like cheating, but what is cheating? Well, in my mind, first and foremost, what cheating is when one student takes it upon him or herself to give him or herself an advantage that other students don't have. Like, cheating is unfair behavior in my experience or my judgment. So like, cheating is like if we say that nobody's allowed to use the internet when they take this test, and then one person just decides the rule doesn't apply to him or her and just like uses the internet, whereas everybody else is trying their best not to use it, and everybody else has to memorize something, and one person doesn't memorize it because they go onto Wikipedia or whatever. Okay, that is cheating. That is one person like getting an advantage that somehow they think they deserve, but everybody else like didn't get. That's cheating. What we say is, as long as we say that you can all do everything, and as long as you, in fact, we say in advance, you can all help each other. And in fact, we feel that you helping each other makes you learn better and is actually one of the harder things to pull off at a non-residential college, and particularly during COVID. It's like really hard to collaborate properly and really hard to be as collegial as young scientists are really supposed to be. And it's really hard for you guys to have the advantage in your learning that I had when I went to college. I did everything in groups. I could not have gotten through my undergraduate physics major or my graduate major, my 2 graduate programs. I couldn't have gotten through if I didn't have a bunch of colleagues that I was really close with, where we all helped each other all the time, and we suffered through all of this challenges together all the time. And sometimes it was like one of us would give us strength to compensate for the other's weaknesses, and vice versa. And sometimes it was just like support, right? I learned by arguing and discussing and sharing and like bonding with my lab partners and my colleagues and my friends in the major. Like, for real, I think it's already hard enough for you guys to do that when you don't sleep at the college, let alone now during COVID, where you practically and I know that many of you are back on campus, but still, I think masks alone, and of course I believe in them, but I think masks alone make it hard to communicate in the ways that some of us used to and some of us still do when we're like doing science. So I think collaborative stuff is like not a cliche and not a joke. I think it's like crucial. I don't think I could have gotten through something as hard as physics without collaboration. So long story short, short story long, when you get this test, when it gets posted, 2 Wednesdays from this Wednesday, November 10th, we're saying from the get-go, you're allowed to talk to other people in your class. In particular, you're allowed to help each other with this thing. And one of the reasons we're saying you're allowed is so that all of you understand that all of you are. So none of you can actually like give yourself an unfair advantage that your other colleagues, just because they're honorable or moral, don't have, right? You will be allowed to talk with each other when you get this exam. And you will be allowed to go on the internet and do everything, blah, 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 blah. And you certainly will be allowed to use your notes from this class. What's the catch? What's the catch? There's no catch except for the one catch, which is that when I grade the exams, I'll know that you know that I know that you've had all those resources available to you. So when I grade the exams, I'm grading them as though at some level it was a research project on your part, like that you had every resource available to you to learn the material as best and as deeply as you possibly could, even if for some of you that's at the last minute, even if for some of you weren't learning as we went, but you were learning in the 5 days that you had the exam. Okay, that's life. That's called like doing work. When I get the exams from you, and this is why we've been practicing this on homework and stuff like that, what you're going to show me in your solutions is all the work. What you're going to show me on paper is not the answers to the questions, because I already know the answers to the questions, and I know they're all over the internet, and I'll know that in some cases I will have even given them to you. Your job is not to show me the answers to questions that I already have answered in my mind. Your job is to show me that you understand why the answers are the answers. In other words, your exam is a bunch of proofs. You're proving why or you're deriving, if you like, you're proving why the answers actually are the answers, why the answers actually do make sense to those questions. And you're proving that you see that understanding and hold it authentically in your mind. In other words, the one test of this whole test is that by the time you write something down on the exam and hand it in, it's not that you have to footnote it or cite it. You don't have to say, I got this from Khan Academy, or I got this from my friend Ed or Charlie or Lakshmi or whatever. You don't have to say that. Like Charlie can help. I'm just using random examples, but like you can be helped by Charlie as much as you want, or Charlie can be helped by whatever, by Lakshmi as much as he wants. But the help that Charlie will get from Lakshmi or Soad will get from Charlie, the help is help in understanding material, so that by the time, and again, I'm just using random examples from the class, right? But by the time Soad hands me an exam and puts her name on it, she's not claiming that she made up physics. She's not claiming that there isn't any source out there that doesn't support what she's saying. But what she's claiming is that every single thing that she writes down on the piece of paper, now, by the time she's written it down, she understands and makes sense to her, which is why the more she writes down, the more diagrams she gives, the more justifications, the more she follows the 5-step problem solving method that we like practice in homework, or the more different colors she uses, or the more she really filters everything through her head and her personality and then expresses that on paper, the more authentically it's clear she gets the physics. And that's what I'm grading it on. And that's not to scare anybody at all. I mean, hopefully, I mean, it's an opportunity people can do really well with this. But it's like, if you've been doing the homework and stuff, you know the difference between writing something down that you've heard versus writing something down that has filtered through your perspective on life and your understanding. And a lot of things on Soad's paper will look just like, hold on, I'm just switching for 1 second, I'm sorry. Yeah, like a lot of things on Soad's paper, of course, will be seemingly identical to a lot of things on Jayla's paper or on Farouk's paper. Like, of course, like the equation on this thing, like 1/2 AT squared plus V naught T equals X minus X naught, like that'll be on both people's pieces of paper. But believe me, the more you write it down your way, the more you, by the time you get to the exam, you're writing down your work. Believe me, after 27 years or whatever of doing this, the more I can immediately tell the difference between, even if Farouk writes the same equation as Jayla, I can tell, believe me, whether what Farouk is writing down is something that is existing in his mind and is then getting translated through his pen onto the paper, or whether it's just something that was in Jayla's mind that then just ended up on Farouk's paper. It's not about citation. It's not about quotation or anything. It's about like showing every step. So anyway, I'm talking way too much, but anyway, of course, I'm reading the whole point. Point is the exam is not this week and it's not next week. It'll be in 2 weeks. You will have practice before then. You will have a lot of solutions before then. You will have 5 days to do the whole thing, but just make sure that your goal, and even if there are certain things that you don't start, I mean, honestly, and this is the way I used to take, we used to have a lot of take-home exams and stuff when I was an undergrad. And there was a lot of times that I didn't understand. Like I only started to actually understand the material as I was being forced to put it together in the exam, just like in a research paper in a history class or something. Like that happens. That's not cheating. That's called, like, that's why we have exams, to force ourselves to get things. So for some of you, stuff might be coming together as you're doing the exam. Great, like Quark bless America. But just the point is make sure it comes together before you turn it in rather than like not at all or afterwards. Okay, so anyway, all right, that was a long, if you have, so we will talk about it more as we get close. If you have any real logistical issues, please do let me know privately, either by email or it could be in the direct chat, although I'm a little nervous. I think the one thing I'd like right now in the chat, like before I go on, like back to physics, is can I just get any kind of confirmation either in the chat or with electronic hands that you've like heard this, that you're confirming that you understand that in principle the exam is okay. Great, thank you. So in principle the exam will be handed out Wednesday, November 10th. Okay, I see like 3. Thank you. Awesome. Thank you. Oh, great. No, thank you. Okay, awesome. Thank you. That's great. I'm even gonna. Great. Thank you, Alyssa. Thank you, Charlie. Thank you, Daniela. Thank you, Jayla. Thank you, Soha. Thank you, Vivian. Thank you, Lakshmi. Okay, I'm gonna take that to mean. Okay, and I'll put this in Google Classroom to great. Thank you guys. Okay. As you can see, exams make me like more nervous than they probably make some of you. I mean, I hate them. I mean, I hate them more as a student, but I don't really like them as a teacher either. But I do believe in them. Okay. All right. Let's go back. Let's do some physics. And in fact, yeah, let's do some physics. This is everything I'm going to say right now is in the context of homeworks 4 and 5 that we were going over. But right now I'm going to do some equation things just in the abs, like they're in the context of those homeworks, but they're not about any particular problem. I kind of want to just, so please take notes or whatever. This is like stuff about constant acceleration. It's about constant acceleration, which is what we were doing in homeworks 4 and 5. Just get myself readjusted. So Okay, a couple of quick things just to summarize where we are so far. I think, first of all, I think we have 4 equations so far. Okay, 2 are definitions that we've been, okay, cool, that we've been churning through sort of over and over again, the definition of average velocity, the definition of average acceleration, right? Then we started imposing this condition. We start saying, what happens when acceleration is a constant? What happens when there's a change in velocity, but the change is not changing? Like that's sort of been the context for the last couple of weeks. And what we've been saying is when that's true, when acceleration doesn't change, then 2 things follow. One, the average velocity is the average of velocities, right? In other words, equation 3 down here. That, again, that's only true when acceleration is a constant, but when acceleration is a constant, it is true that the average of velocities is the average velocity. Then also, now to bring us really up to speed, the very last thing I said, very last class, and I think I didn't say it directly to you. I think I said it on the video for the other class. So thank you very much for watching. And if you haven't, please do. That very last equation, the 4th equation on the sheet, the newest equation to us at all. Of course, some of you might remember it from high school and stuff, but that last equation, what that is, if you look at it carefully, first of all, it's only true if A equals A naught. Like it's only true if there is some value for A that you can plug in at all for A that's not changing. In other words, it's only true if acceleration is a constant. But what it is, when acceleration is a constant, it really is just literally a smashing together, a mashup of the first 3 equations. It is literally the V bar equation, the A bar equation, and the other V bar equation all smashed together algebraically and rearranged to give us one method, one plug and chug way of solving for displacement when what is known is constant acceleration and time and initial velocity, right? It's like literally that last equation there is like the distance equals rate times time concept for situations where by rate, what we mean is rate of acceleration, right? Like again, or to say like again, I'm sort of just trying to put it in perspective because that last equation on the sheet, which we use all the time. Again, many of you may remember it from high school. It may be what you think of as the heart of physics. Like for many people, it sort of is. It comes up a lot. It's something that people plug into a lot. I want to make sure that you don't just blindly plug into it or that you know when to use it. That last equation is what you use when you know the rate, the constant rate at which something is accelerating, and you know for how long it's doing that, and you wish to know how far it gets. Now we're going to keep practicing that and keep using that. The reason it's so important, the reason I'm like pausing on it is like, I mean, this is like the advanced sophisticated version of saying distance equals rate times time. But please note, like, yeah, like distance equals rate times time is a very deceptive, overly simplistic thing to say in English. Like what is true is that if something is going at a rate, if the rate that's given is an average speed, if something, or average velocity, let's say, if something is going at an average velocity of 30 miles per hour for 2 hours, then yes, it travels, okay, 30 miles per hour for 2 hours, it will travel 60 miles. I honestly believe that most people do understand that, like whether they're in a physics class or not. I think most people are comfortable with that and do that in their heads, whether they're thinking of it as physics or not. If something travels at 30 miles per hour for 2 hours, it travels 60 miles. If on average it's traveling 30 miles per hour for 2 hours. But what we're saying here in physics is that the sort of the nub of the gist of physics is if something's accelerating at a rate of 30 miles per hour squared, if something is accelerating at a rate of 30 miles per hour, right? And it does that from rest. And it does that for, let's say for 3 hours. There's a reason I'm saying 3. If it does that for 3 hours, it's way too easy. If you don't know physics and you're not thinking about physics and you just hear those facts, oh, 30 miles per hour squared acceleration rate for 3 hours. Oh, Okay, and if it started at rest, oh, I guess it would go 90 miles is what it's, if you just always think distance equals rate times time, it's, and I don't want to like say this too many times because it's wrong, but it's very easy to think, oh, 30 miles per hour squared for 3 hours. Oh, I guess that's 90 miles. What I'm here to say is like, no, that is wrong. That is wrong. If something is accelerating at a rate of 30 miles per hour squared for 3 hours, it doesn't go 90 miles. Like that's wrong. What does it do? Well, one thing you could do now that we spent all this time like trying to establish the nuances, the distinction between acceleration and velocity, you could plug into that very last equation. From here on in, you could plug into that last equation. And if you plugged into that last equation and you plugged in blindly, you probably get the right answer. But then I'd also be concerned that if you just plug in blindly and stuff, you might not know why it worked or what you were doing or where it came from. But if you plugged in blindly in that last one, you would find that, and maybe you're doing this right now as I'm speaking, or maybe someone wants to put in the chat, but I think if something accelerated, and this is good, like quick practice before we move on to bigger and better things, if something accelerated at a rate, maybe I should pause on that. Well, if something accelerated at a rate of 30 miles per hour squared, and it did so from rest, like, and I have to say that, right? You see, if I'm giving you an acceleration rate now, I'm giving you a rate at which velocity is changing. So if I want to complete the question, I not only have to say how long it's doing that for, like say 3 hours, but I'd have to actually give you this extra bit of information that its initial velocity, let's say for this example, is 0. Right now, I've given you enough facts to actually plug into that last equation. If you plug in blindly, or if you plug in at all, you will find that the answer is, I believe, 45 miles, something that's accelerating at a rate of 30. And please do, like, you can put in the chat or not, but please do, like, since I'm babbling here, you really might want to take a pen and paper, just check that you're following me here. According to the last equation, is something accelerated at a rate of 30 miles per hour squared for 3 hours, but it did so from rest, like its initial velocity was 0, it would travel a full displacement of 45 miles. A, please check that I'm right, or that you understand that according to that equation. But B, what I'm really trying to say, and this is the kind of thing you would put in the test stuff, that like that equation actually makes sense. It's not magic. It's not a formula that I just pulled out of nowhere. And it's not something I discovered in the lab. It's just an algebraic result of the sense, the logic behind the other 3 equations. What I'm really saying is, and please check me with, like, really do put something in the chat if you either have an agreement or an issue with this. What I'm really saying is, if something's accelerating at a rate of 30 miles per hour squared, right, accelerating from rest at 30 miles per hour every hour, that, no, actually, I don't even, sorry, did I say 45? I don't even mean 45. Sorry, that's not even right. Oh my God, I'm crazy. I'm losing my mind. I mean 135 miles is how far. Now, someone definitely better check me in the chat, because now I'm like contradicting myself and making a mess out of the universe. I think it's 135. And I'm doing that in my head, but I'm not plugging into the equation in my head. I'm doing it in my head in a way that I think the equation is captured. This is what I'm saying. But check me, seriously, someone check. I think it's 135. Am I going to actually do it in the thing? 9. I really am losing my mind. Yeah, no. Yeah, 135. If you check the equation, it's 135. But where am I getting 135? I'm saying, I'm getting nervous that no one's putting anything in the chat, but I think it's 135. And I think you'll find that it's 135 if you just plug into that last equation. Like if you plug in if you plug in 3 for T, and if you plug in 30 for A, and you plug in 0 for V naught, I think if you plug into the last equation, you'll get that the total displacement is 135. Wait, I'm going to pause for a second and just see. Can anybody put in the chat either that you agree or disagree, or you've lost me, or anything that I'm saying? I should write this down, right? All right, I'll write this down. I'm losing everybody, I think. Okay, I'm really going to pause because I think I'm talking too fast about too little. This is the problem that I'm saying right here, right on the board right here. I think it's an example of how what equation 4, our most recent equation, the equation that came at the end of last class, the video. I think this is an example of how equation 4 works. I think I've said the answer now, but I'm going to wait. I would like anybody in the chat to put the answer to this question. You can plug straight into that equation if you want to, and hopefully you'll get the same answer I got, and hopefully you'll see it as an example of how to use that equation. But I also want to say why it works. But if anybody could put in the chat either an answer to this question, even if it's what I already said, it would show that you were listening, I guess. I mean, either work it out, put an answer in the chat, or put the answer in the chat that you think I already said, or put in the chat like, I lost you 20 minutes ago. Yeah, Ram, could you please get a new job? Something, just because I feel like I'm like off in my own little world here, or that I freaked myself out talking about the exam for too long or something. So this is the question on the docket right here. It's not a homework question as such. It's just a question. I'm going to pause until I see something happening in the chat again. Oh, cool. Thank you. Alyssa gets 85,000 points for Alyssa. She just saved my soul. Thank you, Alyssa. And can I get any? And I'm not even saying she's right, even though I totally am. But I'm not even saying she's right, even though I totally am. But I'm just saying she just put something in. Thank you. It totally shows it. Cool. Thank you. And I was just, and cool. Someone else just in the direct chat, whose initials I'm not going to say, just put something in the direct chat. Please, other people too. Like, it's not too late. Even if you think I'm saying that those two people are right, which I totally am, like, it would still just show that you're with me. Like, you could put, or at least it would show. Great. Thank you. Awesome. Oh, and by the way, thank you, Jayla. And I'm not mentioning the other person because I put in the direct chat. You could do it either way. But like, two people now in the public chat have at least agreed with each other. That's cool. Thank you. Awesome. Thank you, so on. And by the way, folks, and thank you, direct chat person whose name totally does not rhyme with the thing that it rhymes with that I'm not saying, but thank you. And you're totally right, direct chat person. And by the way, all of you, and I know this is like all silly weirdness, but again, this is so hard to be in a Zoom class, isn't it? Right? I mean, like, it's just so hard to sit and focus. Like, I will do anything to keep us. And there's something I put in the game turn assignments. You might have noticed, I believe I put it in recently, like last week. There's a new aspect to the game where you don't just get points for like doing stuff in the chat and then getting points for that. But now there's like multiplayer co-op is the new dimension of the game. Yes, it was always someday going to happen, wasn't it? Where you now, like, literally, and it just happened, like, just to really enforce to you that it doesn't matter. It's not a competition of saying things first. It's just like us all trying to be a group. So there's a new thing now. Like, if you literally like respond to something someone else said, I mean, you can read the instructions on your own, but if one person says something and another person like literally acknowledges that first person and responds to it and somehow keeps the conversation going, like even basically saying like, yes, I agree with Soad, I also got 135 or whatever, or I agree with Alyssa, like, and you submit that, you get points for doing that, for acknowledging the existence of another person in the class. And if you do it right, they get points also. Like, literally, like, look at the instructions. I don't even remember them at this point, but I'm also going to do another version soon if that works out at all. But like, we're literally saying from here on in, if you even acknowledge the existence of another person in the class and do so in any respectful way, which means you don't say like, that idiot got 135, but obviously it was 136, their house should burn forever. Like, don't do that. But if you do something respectful of the other person, whether it's agreeing or disagreeing, but somehow, then you'll get points and that person will get points for your having done that, and blah, 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 if you both submit. So just look at the instructions and you just note it just happened. Like when someone here, yeah, when Jayla is saying I got the same as Alyssa, that counts for multiplayer co-op, the new sensation that's going to wipe Nintendo off the map. Okay, anyway, I'm just trying. I just want attention. Isn't it obvious? You'd think I was a little brother, but I have a little brother. All right. What I'm trying to say. So thank you, those of you who are participating. I believe the answer is 135. I agree with those people who participated. Still not too late to put that in the chat. But let me tell you, yes, it's 135. Yes, because yes, if you plug in straight, 3 squared is 9, 9 times half of 30 is 9 times 15. That is 90 plus 45, which is 135. But also just please think of it this way, at the risk of boring everybody. The reason that equation works is because it actually makes sense. The reason that something that accelerates at 30 miles per hour squared for 3 hours goes 135 meters, if you miles, if you really think about it, is this. If it started from rest and it's accelerating at 30 miles per hour every hour, what that really means is after the first hour, it's going 30. After the next hour, it's going 60 miles per hour. After the next hour, it's going 90 miles per hour, right? If you really think about the logic of what these equations are saying, if it's accelerating at a rate of 30 miles per hour every hour, that means at the end of the third hour, it has reached a final for that moment velocity, an instantaneous velocity of 90 miles per hour. And that means it wasn't always going that fast. It wasn't always going that fast. In fact, it was never going that fast until that very last moment it was going 90, right? At the very last moment it was going 90. At the very first moment it was going 0. At every single moment in between, it was going something in between 0 and 90, but it was always gaining speed at the same rate. Like that's what we're insisting or assuming by saying A equals A naught. By saying the acceleration is always a constant, that means it was steadily increasing in speed from 0 all the way up to 90 for that entire time, right? So on average, it was going 45, right? Again, we could not say this so simplistically if it were not for the assumption that the acceleration were a constant. But since it's always gaining at the same rate, then that means that it spent an equal amount of time going below 45 miles an hour as it did going above 45 miles an hour. Where did I get 45? The average of 0 and 90. Where did I get 90? Because it was gaining 30 miles per hour every hour for 3 hours. 30 times 3 is 90. So it started at 0, it went up to 90. On average, it was going 45, and it did on average. So it was equivalent to a car that was just going 45 the whole time. That's what an average means, right? If we had to pick one number to represent what this thing was doing the entire time, now it never was doing anything the entire time. It was always changing. But if we had to pick one number, the only number that we could act like it was the one thing the car was always doing, that's what an average is. So on average, it was going that middle speed of 45. On average, it did that for 3 hours. So it was as though it was a 45 mile an hour car traveling for 3 hours. 45 times 3 is 135. That's what that equation is actually trying to capture. I just really want you to understand that. That equation, you can plug and chug in now blindly once you get it. But please understand, we didn't just make it up. All it is that concept being put together algebraically, that equation, okay? And if there's any questions, you'll put them in the chat. And if not, I'm going to go on to a next equation now. Like now I'm going to move a little, okay, if that makes sense, that equate, and okay, so that was our fourth equation. I want to give you a fifth now before we go on. Oh, but one other thing I want to say, notice I'm being sort of fast and loose sometimes with X naught. If you go back to this page, if I go back to this page, yeah. Like it might bother some of you that sometimes I write in the X naught and like sometimes I don't, or it looks like sometimes I just ignore it or something. The X naught, right? That's in the first equation, that's down there at the bottom of the fourth equation. I just want to remind you that X naught means position at the time of 0. I mean, position when t equals 0. The very first position. The initial position. That's what X naught, X sub 0 means. Now, please notice that we've got these 4 equations that are going so far, but we also have a concept that's been driving this class sort of more in English on the side. But we have this concept, but it's going to come up. It's going to come up and dovetail with the equations believe. And that concept is Galileo's principle of relativity, GPR. We've had so far we've had 3 forms of this principle. I don't have room to write them all down. Now they're English, they're a little bit long. We're going to get more forms of that, just like we're getting more equations. We're going to get more forms of that principle. And they are going to start looking more and more mathematical. Now, for the moment, the forms of those principles are English and long enough that I'm not writing them, but they are. The laws of physics hold that the laws of physics are the same at all constant speeds and directions, or at all constant velocities. The laws of physics are the same at all constant speeds and constant directions. That's form number one. Form number two was, therefore, there's no experiment you could ever do to measure the absolute velocity of something through space, of one object through space. Like you could never measure the velocity of a single object just going through space because the laws of physics are always the same at all speeds. So no matter what speed you're going, all experimental results would work out the same. So you can never tell what speed you're going, if by that you mean compared to space itself. So then form number three was, since we can never do an experiment to find out, like we can know that the airplane is going 50 miles an hour past the clouds, or that the clouds are going 50 miles an hour past the airplane in the opposite direction. But to actually know what the airplane is actually doing, like in space, like as a single object in and of itself, apart from the clouds, to actually know that, you cannot do an experiment to find that out, because no matter what experiment you do, you're going to get the same results because the laws are always the same at all constant velocities. Therefore, form number three says, therefore, there's no meaning to the velocity of a single object through space. All velocities are relations between pairs of objects. There's no such thing as a velocity of just a single object. That's what form three said, right? In other words, all velocities are relative. Okay, that's what GPR says off on this. Now, what does that have to do with these equations? Well, one of the implications of GPR means that then everything is a comparison. There's no objective velocity or position to an airplane. There's the position and velocity of an airplane compared to some second object you choose as a reference frame or as a reference coordinate system, such as the clouds or such as earth, ground below the airplane. That everything is a comparison and answers differ depending on what we're comparing things to. So in physics, we not only can, but always must choose what our reference frame, our reference object, our reference coordinate system, our reference grid is. We have to in physics, because there is no velocity that is objective in and of itself related to just one object. Everything is in comparison to a choice that we make. So we choose our coordinate system in physics, and therefore, what does this all have to do with each other? Therefore, whenever we start a physics problem, and this is when you make a diagram and when you're taking an exam or something like that, when you're starting to solve a physics problem, you begin by making a diagram and by choosing where the zero, the origin of your coordinate system is, choosing what direction is positive, choosing what direction is negative, et cetera, you get to choose where the zero, the origin of your coordinate system is. Generally speaking, if we're only studying one particular object, like a car going down the highway or something, we would generally choose to make the origin of our coordinate system right at wherever that object started. So generally speaking, because of GPR, because of Galileo's principle, because we have to make a choice anyway, we will generally choose to make the very first spot that any object it happens to be, we'll call that zero. So generally, this is where the red comes in on this sheet. Generally, I'm saying like this term here, this term here, frequently will be zero just because we choose it to make things that way. It won't always be. That's why we have to include it in the equations. When might it ever not be? Like, when would we ever not do that? We'll say we're literally tracking a bunch of objects at the same time. Say we're having a race between a bunch of sprinters, and and some of them have head starts or delays, and they don't all start at the same starting line. Then we can't say that they all start at zero if they all don't start at different places. So sometimes we have to take into account that X naught term. That's why it's part of the equations. But when in doubt, frequently, I just make that thing zero, and that's why it disappears sometimes from the equation. So you have to just sort of get used to that, and that's where practice comes in. Okay, But those are the equations we have so far. I know I'm kind of all over the place here, but those are the equations we have so far. I want to just blast forward and derive a new equation for you, like in the same way that I derived the others. Okay. So I'm going to continue to assume that acceleration is a constant, right? Okay. So what the situation I'm talking about now is imagine some kinematic situation, like the ones we're talking about, a situation where an acceleration is assumed to be constant, like not changing, perhaps is even given as part of the problem. And we're trying to predict, as we usually are, like how far something goes. But let's say we're not given any information about the time. And let's further assume, and that's what it says here, let's further assume that we're also not solving for the time. In other words, all these equations have time in them. So all these equations either are solving for something using the time, or they could be rearranged perhaps to solve for the time given other information. But let's say that time has nothing to do with what we're saying. Is it even possible to answer questions? Like example, and the answer is yes, it is. Okay, this is totally illegible. Of course, I'll just read it out loud. I will recopy it on the next sheet, but I know we have 13 minutes. But I'm saying, here's an example. Let's say we have a car that accelerates at a constant rate of 5 meters per second squared. Okay. And now let's say furthermore that I'm going to start being more advanced. Let's say the car doesn't start at rest. Okay. There's no reason that all these things always have to start from rest. They can start at any initial velocity they want. I've been using 0 for a while just to be soft and fuzzy, but let's assume that the car starts already at an initial velocity of 10, not of 0. And you might even say, by the way, how's that even possible? How does a car start from something other than 0? Well, two things. Number one, start does not mean the Big Bang or the Garden of Eden. Start means when we start paying attention, right? I mean, it's true that probably most cars, if they're going to be driving, like they probably at once upon a time were parked. But the point is, let's say the car was parked, it starts moving, it gets up to a speed of 10 meters per second, and that's when we start paying attention. That's when we start collecting data. That's when we start our stopwatch. That's when we hit go, right? Just like, by the way, very important to know, this used to confuse me all the time, just like people will often say, especially in forensic science, they'll say, a bullet emerges from a gun at an initial velocity of 200 meters per second. That is frequent, like that's a common number, that's a real number. And you hear that all the time, like the muzzle speed of a gun is 200 meters per second. A bullet comes out of a gun at 200 meters per second. That's also, by the way, like saying someone pitches a ball at 50 or 40 meters per second. You might say, wait a second, doesn't the bullet first have to be at rest before? And yes, at some point it does, but by the time it comes out of the muzzle, it's not at rest anymore. If it were at rest, it wouldn't come out of the muzzle, right? The idea is the whole point of the muzzle of the gun is the bullet in a very short amount of time accelerates at a very high rate so that by the time it comes out of the gun, by the time you start your stopwatch and start paying attention, it's already going. Or when I throw a ball, yeah, I bring the ball from speed of 0 up to a certain speed, but I do that with my hand while my hand is touching the ball. That's the point of moving my arm. By the time the ball comes out of my arm, it's going at a non-zero speed, right? So initial speeds, long way of saying initial velocities, initial speeds, V0 are frequently not 0. If they were 0, not much would happen at all. Okay, so those, X naught is often 0. V naught is often not 0. So in this example, right, I hope that's sort of clear. So in this example, let's say we have some car that has an initial velocity of 10 meters per second. Like we started paying attention by the time the car was going 10 meters per second down the highway, and it's accelerating at a constant rate, 5 meters per second squared, let's say. And we let this car go until it reaches a velocity of 10 meters per second. I mean, maybe it keeps going then on. Maybe it goes up to 105 and then 110. But we stop paying attention when it gets to 100. And the question is, how far does this car get? Okay, that's the example question we're going to do right now. Now, I want to tell you, especially since I have 10 minutes left, especially if you're getting bored or if I'm going too slowly for some of you, which I could imagine, and I apologize if that's the case, but you could start working on this right now. You could get an answer to this, and you can totally get it with the equations that we already have, the 4 equations or some combination of the 4 equations that we already have. I am assuming constant acceleration here, so any of those 4 equations will apply. You could right now, and it might be a worthy exercise, if you like, you could start trying to solve for this right now. You can even put answers in the chat if you want to. But I want to tell you, you're going to have to use more than one equation, because if you think about it, any one of those equations that you have, they're either requiring time, and I didn't give you time here. Well, all of them are requiring time, and I didn't give you time here. So what you could do, if you want good practice, you want to keep alive, or you want to you want to break from my voice, what you certainly could do is practice your algebra skills, and you could use these numbers to solve for time, I suppose. And then you could use that time to plug into some different equation and get the answer. Yeah, in fact, you totally could do that in this case, and maybe you should. You could solve for time and then plug the time into some other equation to get the answer. That will take a little bit of work. Not a lot of work, but a little bit of work. I think, in fact, I think we could do that. I think, well, yeah. I think that if you look at the equations, you'll find that you could solve for that. If you're looking at this and you're with me, you could look at these numbers and see that this car will take 18 seconds to go from 10 meters per second to 100 meters per second, accelerating at a rate of 5 meters per second squared, right? If you look at the definition of acceleration, you'll see, oh, it's got to increase its velocity by 90. It's going from 10 to 100. It's got to increase by 90. It's increasing 5 every second. So what's 90 divided by 5? I believe it's 18. Yeah, it's 18 seconds. So this thing will take 18 seconds. And I'm asking how far it will go, so that if you're really with me, this is a good test. I mean, if you can either do this on paper, if you could do this even on paper, I think you're good. If you could do this in your head with me, you're really good. I think this car is going to take 8, but I'm going somewhere. I'm about to give you a new equation is my ultimate punchline of this with the 7 minutes we have. But I think we can see this thing would go 18. It would take 18 seconds for this thing to do what it's claiming it's going to do. Take 18 seconds. If I want to know how far it's going, I need to know how fast on average it's going for those 18 seconds, right? I mean, once I get that it's 8, oh, nice. Yes, that's awesome, Miss Mrs. or Mr. direct chat person. Yes, I totally agree with what you just put in the direct chat. That's great. And you should totally submit that for points. Yeah, that's awesome. That's sort of what I just did in my, yes. I'll just say yes. So if you did that with the direct chat person, just like rearrange something to get the time, they would then get 18 seconds. Now I'm going to say, and I hope everybody follows this, this car is traveling for 18 seconds. I could now plug into the fourth equation, or I could do the same thing did in my head a minute ago with that fourth equation. I could say it's traveling for 18 seconds. And on average, it's going 55 meters per second. On average, it's going 55 meters per second. Where did I get that? I got that from 100 plus 10 divided by 2, right? On average, like it started at 10, it's going up to 100. So on average, it's going 55, because 55 is like 45 above 10 and it's 45 below 100. It's going 55. So this is equivalent to a car going on average 55 meters per second for 18 seconds. So the answer to this whole thing should be 55 times 18, which I think 55 times 18 is like 55 times 2 is 1,100, but minus but minus 1,100. So I think it's 1,990. I mean 1,090. I think is the answer to this whole thing. I can't do 18. Yeah, 8. Well, we'll find out in a second. But I think the answer to this whole thing is 1,090, I want to say. We'll find out in a minute. But that's a lot of work I just did in my head, let alone on paper. That was a lot of work. Is there any faster way I could do this? But we'll see if that's the answer in a second. Here's what I'm saying, and this is based on what someone in the direct chat just did. What I'm saying is, and this is the last thing we're going to do today. What I'm going to do is, instead of going through all the steps that I just did with the numbers, I'll do all the steps with just the letters, with just the equations. In other words, I'll do algebra so I could do it once and I never have to do it again. In other words, displacement equals average velocity times time, right? I mean, that, which is to say this, sorry. Here, sorry. Right, average velocity equals displacement per time. So I rearrange that and say displacement equals average velocity times time. Then I say, oh, well, by average velocity, in this case, if we're assuming, and we are, if we're assuming that the acceleration is a constant, then I can say, okay, displacement equals average velocity times time, right? And average velocity is the average of velocities. I'm using our different equations and I'm putting them together, right? Then I'm saying, and this is the part that someone in the direct chat just put in, if average acceleration equals change in velocity per time, then that means, this is what someone put in the direct chat, that means I can rearrange that and say time equals change in velocity over acceleration, right? That's just like cross multiplying and dividing both sides, but I did it a little bit fast since we're running out of time, but you could check. I just multiply both sides by t and then divided both sides by a, right? So I can plug that in. I know we're just about out of time, but I can plug that in right here. Okay, that's what someone in the direct chat very wonderfully just said. So now I'm going to do that. I'm going to say, oh, then displacement equals average velocity times time. And I'm going to go to the next page, and we have 2 minutes. We're just going to, I know it's getting sloppy. I'm just going to recopy that on the next page. But all I'm doing is algebraically smashing together the equations that we already have, right, in order to solve for what we need, right? So now I have this. right? And what's on top? On top is the difference between two perfect squares, so to speak, right? In other words, well, you could FOIL it if you like. I'm just multiplying what I have this. Oh, sorry. Whoa, sorry. That was just a typo. That's supposed to be an A. That's supposed to be an A. And did I make the mistake on the other? No, I didn't. Okay. And the time is just about out, but this is what I was trying to get to. This is our fifth equation, if you like. And again, this assumes this last equation. Okay, so now we have 5 equations in this class, and that's it, by the way, for kinematics. Like, we actually, for the whole nature of constant acceleration motion, which is what we're looking at right here, this is the last of any equation we're getting, and then we can move on. But this fifth equation, what it is, it looks like black magic again. It looks like a formula. It's the equation that you use when you don't know anything about the time and when you are not being asked to solve for the time. Any situation that has nothing to do with time, you can use this. Oh, and sorry, class. And so to do our question right here, just to finish this class, sorry, but this is our last equation. And all it is, or what I'm saying is, it's not new information. It's just an algebraic smashing together of our other equations. It's just a convenience. You never need it. It just makes everything convenient now. So like in a problem like we did here, we would do 100 squared minus 10 squared all over 2 times 5, which is 10. And so we would get 100 minus, yeah, actually, like we said, we would get 10,000 minus 100. So we would get 9,000 divided by 10. I believe we would get this. All right. 10,000. So 10,000 minus 100. That's it. Yeah. No, and sorry, that's it. That's class. I'm sorry. We're done. That's it. Thank you for your patience. Sorry I was so scattered today. Thank you. No, everybody have a good day. We are done. Thank you. Thank you.
Thank you. Bye.
Bye. Bye. Thank you. Thank you.